See that. Cool.
All right, Bryce.
All right. Cool. Well, I guess we'll start the meeting now. Hope you all have been having a good midterms week. I know that haven't had the best one yet, but hopefully y'all are doing pretty good. This meeting will be talking about Windows forensics. Is kind of a response to the privilege escalation Active Directory meeting. So hopefully you see some corollaries between those. And yeah, I guess we'll get started. And like Michael said, we'll hit the announcements at the end whenever we're done with this. So be back to these in no time. Here, I think that's our meeting flag. Well, you're going to find out real quick. Don't worry. Yeah, put that in. All right, brief overview. There's a lot of stuff to cover. The Windows operating system is a massive monstrosity of things that they cobbled together over the last few decades. So we're going to talk about a lot, hit on Event Viewer, what the registry is. I'm sure you've seen it from the flags. Some artifacts from the new technology file system that Windows runs on, about how Windows processes work, execution activities, linking activities to specific users, how to actually collect that evidence. We're going to breeze past that pretty quickly. And then we're also going to go through how to hunt for scheduled task persistence. It's just like something fun you can also do on your own computer. And then finally, we'll talk about Active Directory group policy objects. So it's going to be a lot. Okay. First thing to talk about, Windows registry. So this monstrosity is just a massive hierarchical database that stores the different configurations that different applications and services run on in the Windows system. It's persistent storage, so no matter how many times you're booted or shut down, it's going to stay the same. To pull it up right now, you can open the registry editor if you're running Windows. If you're on Mac or Linux, unfortunately can't do this. You just hit WinR and hit regedit, or type in regedit, and you get to see that beautiful screen of all the different keys and values and subtrees to pull through. All right, as I just said, guess what's in a registry? Keys and values. I'm glad you all know it. So what a key is, it can be two things, either a subkey, or it can have subkeys in it, or it can contain like certain values. So in this example here, you have two Docker subkeys with the original Docker key. And within the second subkey, you have different values. One for like the actual path to where the application is stored. You have like the version numbers, the uninstall identification. So this is just kind of how like the hierarchy is stored in the registry. It's pretty simple once you get to see a thing or two. And you can have all sorts of data types in this. It doesn't just have to be strings, and so you can have all sorts of wonky stuff because Windows is like that. All right. And at the top of the registry, you have 5 main subtrees. These are basically like your root nodes. If we're thinking about like, I don't know, any sort of other regular trees that you might have seen in like a data structures course or anything else in your time here. There's basically like what the root of the registry, and there's not any specific data in them, but they contain everything else inside the registry. There's those 5 ones that contain everything. You can read through them all, but the ones that we're going to be more concerned with are the HKey current user, which is all about the user that's currently logged into the box and what they're doing, and then also the local machine, which has the configurations for the entire box as a whole. And those are 2 big ones that we're going to be looking at. Any questions about the registry so far? Cool. All right. And then we go on to the hives. Hives are just logical groupings of the permanent registry keys. These are stored on your disk at system32 config, and these are updated with every login. These 5, the SAM security software system and defaults, those are the most important to forensic investigation. I'm sure you can draw that conclusion pretty easily, given that SAM stores local user accounts, passwords, and all that jazz. Security stores different information about like logging policies, audit policies, all that jazz, what software is on there, different system events. Default also contains all the configurations for the local system administrator. That's pretty useful because attackers like to get that, and that's basically the equivalent of root for Windows. So those hives. All right, and a bunch of additional notes. The 5 that we just showed here, those are not the only hives. There's a bunch of them around here, like amcache and the ntuser.dat file. They're all sprinkled throughout the registry, and they all just a bunch of logical groupings of everything and anything that Windows wanted to put together. All right, and a brief history about the registry. This isn't very important, so we're going to breeze through it pretty quickly. Prior to this, transaction logs were kind of like a cache for the registry. So like every time you made a change that would have caused an edit to the registry, it didn't automatically make that change. It stored it in a bunch and then made all those changes at once. So like if you had an improper shutdown before the changes are written, you lost those changes, but they're still stored in transition logs. So whenever you were performing forensics, you had to take these into account and combine them with the existing registry hives to make those changes. That has mostly been since phased out in favor of like TRX and other writing changes. But yeah, just something to keep in mind. Cool bit of history. And if you're working with any like Windows 7 machines, you will have to worry about this. We probably won't see any of that too much, but just always something to keep in mind. All right, NTFS artifacts. Suchi, you want to talk?
Sure. So this is the new technology file system, and it starts with Windows NT 3.1. Basically, it's a default file system that's received the file allocation table that used to be there before this was put into place. And it's basically a journaling file system. So it'll do a transactional log of all changes, folder creations, modifications, deletions, etc. And then what that can be used for is recovery and from power loss, crashes, and maintain integrity. So basically, if your laptop shuts down, let's say you're running low on power and stuff like that, it'll ensure that your files don't get corrupted mid-crash. This means you can find most of the file and folder activity on this file system, and journaling files such as $MMT, send journal, log file, and $. Is that
I-30. Not the highway, thankfully. Yeah. All right. So the master file table, this is like pretty much the file table if the name didn't give it away for tracking file changes on NTFS system. So every object is like a folder, a file, anything like that has its own record in the MFT table. So it just contains data about like when stuff was created and when it was modified, who modified it, when was it deleted, etc. However, whenever you delete it, whenever a file is deleted, those entries do get phased out eventually because these things can get pretty big. I think mine is around 8 gigabytes on my computer, and if you continue to use it more, it gets pretty hefty because the size never goes down, it only goes up. So anyway, the MFT is stored at the very root of your partition, right at the C drive. Acquiring it is pretty hard, just like if you're running a live Windows machine. With a triaged imager like CAPE, which we'll hopefully talk about in a little bit, you have modules where you can extract that to external storage and then look it through it there, which is pretty cool. So no MFT fields in use. So if this is unchecked, it's been deleted. That's pretty simple. It also has ads. This is not, it contains like ads basically for like, ooh, you should download like Clash of Clans or something. This is much more useful. Alternate data streams for those Mac OS users, this is kind of pertinent to you. If you want to share files that use like the HFS file system to Windows people, this allows it. If once you have those multiple data streams in a file, though, you can hide things in them. It takes a bit of effort, but that is one more thing to look out if you see that bit being checked.
Also talk about alternate data stream.
Yes.
So in Windows, there's a feature called markup web. Basically, whenever you download the file from the web, it will get marked as this, which allows essentially certain applications to take a look at it. And for example, right, if you download a Word document or like an Excel, if it has marked web, it will automatically show like this file is unsafe or on the internet. Do you want to edit it? This class actually implemented with alternate data stream, and it actually contains, I believe, so it's an alternate data stream with like the URL and whatnot from where you download it. So it's just a fun fact that I thought you guys might
It is pretty cool.
something the operating system essentially writes a download record into the metadata of the file.
Indeed.
That's a canonically correct way to implement this, rather than
Indeed.
alternate data stream.
Mark of the web, yeah. But yeah, that's the MFT. Contains a whole bunch of useful stuff about the current state of the files. All right. So looking at actually using the MFT, once you use something like Cape to extract it, you can use RStudio, which if all of you have used RStudio before, it's not the one you're probably thinking of for statistical analysis. This is something else. It was specifically made to read the MFT. Once you do that, or you can use the MFT ECMD parser by Eric Zimmerman. I prefer the latter. It's just easier to use. And also the Zimmerman tools are fantastic in general. And then once you pull out the CSV from there, you can use something like Timeline Explorer or hell, even Excel, and get you to see what's going on. All right. Next up, we have the Update Sequence Number Journal. Now, that sounds like a little bit of gibberish out front, but it's actually pretty useful. So this again provides monitoring of file and folder changes, but again, it contains two data streams using ADS, which guess what? We just talked about that. So the big data stream for a USN journal is J. This holds the the records of changes, all of those things over a file's entire life cycle. This is a bit more comprehensive than the master file table because that is primarily on current changes to the file. USN journal stores them for a bit longer and typically holds deleted files for longer. So it's always good to look here as well. And you can also use the parser by Zimmerman as well. Just example command there. All right. The log file. Can you guess what this one does? Yeah, stores details about low-level changes to provide, again, more resilience to the system. Because whereas USN journal and master file table are more of like general, like a file was changed, it was created or deleted. This is like what exactly happened to the file to actually make it change, which is very useful if something like crashes and you want to restore those explicit changes. Log files what makes this possible. Again, this is again located in your volume root, and you do need a different parser. NTFS log tracker is pretty good. I mean, I prefer to use this one solely for log file. It's not as good as MFT ECMD for parsing the other two, but
What does that stand for, by the way?
Oh, MFT ECMD.
Master file table.
Yeah, and then something command line. E.
That's fine. Keep it.
Okay, I mean, it's kind of bold. What?
Essentially, yeah.
I don't think it's Explorer just because it's mainly used to parse it and you use another application to go through the data. The heck?
Yeah, it's Explorer.
It was
You're
Explorer?
right.
Nice one.
Bingo.
Cool. And that one also has a cool sus behaviors detection. I kid you not, I didn't just not type suspicious out. It is just the sus. I thought you all might enjoy that. There we go. Then we get into I-30. So this is more of just like location tracking. So every time you update folder content, this index is also updated. This is the best way to check for deleted files. So like if someone puts malware in the system and then deletes it later, you're able to find proof of its existence here. It doesn't actually store the contents of the file, but you know that it did at some point exist, and you can go through other methods to try and figure it out as well, or figure out what happened as well. Yeah, you have a different index ripper here to parse that, and then keep analyzing through it. So yeah, so those are the big NTFS, I don't know, artifacts you can go through whenever you're doing forensic analysis on a Windows machine. It's always good to at least give all of them a gander, see if anything suspicious is going on or anything that really stands out. And it's always good to have those on hand whenever you're referencing other data sources to be like, hey, this did actually happen. I have a secondary proof. All right. Cool. Susha.
All right, this is the Windows search database, and it stores the index to speed up searches and help recover deleted files. So basically, even when a file is deleted, it still persists in this Windows search database until it's updated. And then The search index records various user interactions and interactions with files and browsers. This is just all like artifacts that you can use to figure out, if an attacker was able to breach your system and interact with these files and browsers. So it's a good log to have and log to parse. The special thing about it is it logs all URLs access via IE and MS Edge. So any attacks from those websites.
Does that include incognito access?
That's it.
I don't think Internet Explorer has incognito access. That's probably just because Internet Explorer is like from ye olden days. Though Microsoft Edge, I'm not sure. That's a good question.
What do you have Internet Explorer on modern?
Nope, but it does exist for the older versions. So if you do ever work with those, this is one place to check. Yeah.
And then it tracks file openings per user, and it's located at this long applications things, applications Windows.db, and in Windows 11 it's changed to Windows.db for database. And then to parse and explore, you just have to search. So SIDR, SIDR is a great resource for actually like searching and like easily applying and using it like a database.
True that.
So this is processes and child processes. So Windows application starts several things that occur in your memory. The initial boot up, so the application executable flows into memory, which creates a new process. Then this process acts as a container for running memory, holds information about application state, and has its own process ID. Then what's going to happen is the parent process will create child processes that'll execute other functions in your application after boot. So the security privilege that the process runs under is determined by the context of the user who ran the application. So under admin, the processes that you create under admin would have different privileges compared to the processes that you would create under a specific user, like let's say Suchit or let's say Michael. And then these are used to enforce security restrictions and prevent the process from doing certain things. So when you say like sudo to a certain like process you create or a certain command, that process will be created under the super user, and that's why you were allowed to execute certain permissions while using the sudo command. Whereas if you don't use sudo and you're like on a regular user, you wouldn't, that process that you created to execute a command would not have those specific permissions.
And if you remember from Ronan's Windows privilege escalation meeting, this is not exactly that hard to bypass. It can be trivial in some areas. So while it is well-meaning, it is not entirely effective. So yeah.
And another fun fact is that network packet captures can actually show you some of that information forensically at some point later after the fact. So you can actually look at process IDs and things like that.
So parent process is the process that launches the current process that you're running. So every process for the most part, except for like the initial one, I guess loaded from boot, would have a parent process that spawned it. And then you see the relationship between the parent and the child. You can basically understand who is spawning your processes, so you can see from which like user an initial process was spawned. Take, for example, if you use a sudo command, while you're running that process, the process needs to access a certain other information, so it'll spawn its own like child process. If by tracing the tree up, you can basically figure it out, oh, which type of user has actually spawned my processes, and then what type of permissions I have around that. And then the process command line provides important information about their application and configuration. So if you run svc host.exe without the -k, it allows the service control manager to track your running services. So you can basically see the processes that have spawned and their certain applications, like trace up from there.
I'm going to issue a brief correction there. I think that comment was in regard to like an attacker renaming a malicious process. Like, hey, I don't want my malware to be named malware.exe. What if I make it svchost.exe to be a little bit more subtle? If they use the -k flag, which all legitimate svchost.exes use, which allows the service control manager to track it and manage it, it doesn't allow them to do malicious things. But without the K, it allows them to hide in a little bit better, but you can tell it's malicious because it's not following convention.
A lot of malicious behavior will ultimately try to emulate what looks like a legitimate file as part of a broader you know, step-by-step process of how they go about things. So it's very tricky to look out for something you think looks legit by name, and then it turns out it's not. It's making calls to some other thing that shouldn't be normal.
Okay. All right. So whenever you're like, let's say going through memory or of a specific dump process, there's a few things you're going to want to look out for. Parent process ID and process ID are pretty key in this. If something that you know is malicious is spawning a bunch of child processes, that's pretty obvious that you need to look into that. Same thing if you know have a process you know is malicious and you see that Microsoft Word spawned, it'd be like, huh, I wonder where their initial point of access was there for that. So again, just seeing the vertical relationships are very useful. Oh, yes.
It's just like a concept of this. I mean, it's like a EXE DLL sort of combination, sort of a parent-child process.
I'm sorry, can you repeat that?
It's like an EXE using a DLL to execute its stuff. Is there a parent-child or like the DLL as a child and EXE as a parent, or is that a different?
That's a good damn question.
I mean, I think for the EXEs, they're mostly just going to be using functions from the DLLs. I mean, you can be calling, I think, functions both ways. Henry, if you want to pop in on this.
Okay, I mean,
Mhm.
like DLL is a dynamic library.
Mhm.
What it simply does is it exports data and functions. They only export definitions. They are not, they're a separate concept from a process and a threading process, stuff like that. So let's say if you are a binary, you are currently running and you want to load some extra data, right? Or you want to load some extra functions that's provided by other files. And for example, if you're using a lot of operating system features, you might want to just get those from them. So you would do load library, get proc address, and then run the function. Data, similar thing, as long as you can find where it is in the DLL, do it. To spawn a different child process or whatever, I guess there are several ways in Windows that you can do this, but it would just be create process. So what if if inside of your own process you call create process, then you spawn a child process that's running.
Yeah, so if I have like create process within an EXE and I have like, let's say shell code, is that like example of like I have shell code like this, it might not be best, but I have shell. And I have a create process thread like
So a process, I guess you'll understand each other in a system programming course, but essentially, I guess it depends on what your shellcode does. Because if you want your shellcode to just take over the original process, that's fine, right? But if you take over the original process is not running. The regular code is not running. It's running your shellcode. But if your goal is to be stealthy, right? If your goal is to make the process look as normal as possible, then in your shellcode, when you're running your shellcode, you might do create process, and then spawn yourself to another process, and then but usually we use remote threads or local threads or stuff like that. Usually it's local thread is safer. I think remote thread is it looks very sus, so not a lot of people are doing that.
All right. Thank you, y'all. All right. Yeah. A few other things to keep in mind when process was created and exited, where it was run from. So again, if you see like a somewhat legitimate thing, let's just say SVC host again, but the file location isn't where it normally is. It's in like some temp directory. Well, I don't think that's very legitimate. So another thing to keep that in mind. Also gonna know about process command line arguments. A lot of adversaries will often put in the busy work to obfuscate what they're running, like even base64 encoding it some of the times. They just like run with their command arguments clear as day, and you can see those pretty clearly in the PowerShell script block logs and also just in the process tree of that command line. Also keep in mind the process handle, which is like what stuff is associated with the process, who is actually running it, gives you include any potentially compromised accounts, and also what privilege the process is running under. Because if it's under system, you've got a bit of an issue. If it's lower medium, not as bad. Okay, execution activities. All right. Anyone got any questions as of now?
Anybody have any comments they would like to add? Any experiences?
Cool. we're gonna keep on moving. All right, Windows services. Fun stuff, as I'm sure you could tell by the riveting title. So most of this service configurations are stored under the system registry hive, seen there, like we talked about earlier. And these are also, they're under the current control set services key. Most of the time it is control set 001, but there are multiple control set keys that can be used just for different users. Sometimes the Windows OS creates them for various things. I'm not clued in as to exactly why, but there are the different ones, and you can see those, and you can change which ones are in effect at a given time. To make sure that you're looking at the one that actually is in effect, go to the HKey local machine system select and figure out if it's 02 or 03, and you know to pay more heed to those. Also on services, in the system event logs, those are some key event IDs to look out for. The service is crashed, again, if possible process injection or other trickery, 7035, start stop. Also, the service was changed. Yeah, they just, whenever you're going through event viewer or a different event log viewer, those are always good things to query for, and keep refining your queries if you are suspicious about specific processes. Get more information about what actually happened. Yep, and also in the security event logs, the ID 4697, that gives a whole heap of knowledge about service installation. You do have to enable a different audit policy. This is something you can run on your Windows computers right now if you don't have it on already. I'd say make sure to check the command yourself, because I just typed it out from what I had in my notes. May not be entirely accurate. And it's also always good to make sure the command lines you're running are verified by yourself before doing it on your own stuff. So interested in doing that, go ahead. All right. Also, PowerShell script logging. Now, if you remember Ronan talking about how Windows nerfed PowerShell for a lot of offensive activity, this is part of why that is a little bit more annoying, especially for evasion while using PowerShell. So script logging captures, when I say the full content, I mean everything, entire scripts, all of your metadata, if it has, or where it came from as well. This is stored in the operational log files for PowerShell, and it gets all of those fields. And I think post Windows 10, or I don't think this is on by default. They might be changing that in the newer Windows version, because it is a very good thing to have as a defender. But you can just go in your registry if you have regedit open and change that bit from a 0 to a 1, and then maybe try out your own PowerShell commands and check those log files. It'll be fun. All right, Sushi, you want to give it a go?
So these are auto run applications. So basically, if an attacker can persist in the system by adding malware, basically a list of programs that are automatically executed as some sort of. So let's say they were able to add malware at Task Manager, or some, like, let's say Microsoft Teams always starts up when I open my Windows. I need to disable that button. Let's say you were able to inject malware into an application such as that. Basically, you would be able to look at, certain software, current versions run, and from there, what you would do, you go examine that sort of stuff and see, okay, this is always run on sort of what are basically like the attack surfaces that an attacker can use and how they can basically get into these applications. So if you add like malware to the list of these programs, because they, I guess the plus side of this is because they're automatically started on running and booting into your computer, they will start every single time your application is run without the need of you having to specifically click on an application. So it turns from sort of like an n-click exploit to zero-click exploit. So what we can do, we need to like use shim cache, which is basically like a feature to maintain compatibility for applications running on your operating system. So what this is sort of like I wouldn't say a porting, but it's sort of a version control. So when an executable file is run from any source, removable media, network share, entry is made. So you can basically see executables that are merely viewed, in the GUI are also recorded, but they are not executed, which is one of the big things. So entries do not confirm execution of a program. You have to look at it and see this was open, but not necessarily executed. And that's a big thing to look at when you're running forensics, because you want to make sure that you have to be sure whether or not something was actually executed or whether it was just open. And then shim crash entries are stored in the registry at this address. Big address, but you want to use the app compact cache tool by Zimmerman to parse this data. Again, Zimmerman has a lot of good tools for Windows forensics that you can implement. So the AM cache.hve, basically the Windows file protection cache, it contains records of all files that have been installed on your system. So again, a lot of tracking over here, including the name, version, and location. Is located at that location in your C drive and can be used to track the history of installed programs and updates. So basically, let's say you're an attacker, you install a program or an installation. What a forensics expert can do is they can filter by a certain time period. They can see okay, what was installed within these last 5 days. Look at that and potentially filter to see the applications that were potentially maliciously installed on that laptop. And then you'll need tools like AM cache parser. And then one of the most useful fields is the unassociated field, file entries, which contains all installed applications identified as SUF. So basically anything that doesn't follow the regular standards or hasn't been installed across multitudes of Windows computers. So they'll identify, look at their SHA-1 patches to see if they're known malicious. And then you can also use this info to create a blacklist or whitelist. So similar to, I guess, a firewall, you can create sort of a block something that has this sort of signature. Signaturing is a big thing in Windows. If, let's say, you look at a specific malware and it has specific artifacts that you blacklisted, it basically won't allow it to run, which is a very good thing for defenders. Next slide. So BAM registry key, background activity monitor. It's a service that controls, obviously, the activity of background applications. So we run a host of background applications while we're looking at Chrome, while we're playing a video game, while we're doing other stuff. And what this allows us to do, basically, an attacker might try to run an exploit in the background. So, not something that would pop up on your screen and show you, oh no, you have malware, something like that, something very basic like that. Instead, they could try to insert it into a background process, and this will just help you look into all your background processes and sort through that. So again, looking at your attack surface and trying to find ways to find files or find possible points of entry. So then they can be any type of app that can continue to run and perform tasks even when the user is interacting with it, including non-GUIs. Big deal. It's stored in the system hive under the keys, control, set services, yada, yada, yada. So they provide info about the executable files that were run, full file path, last execution, date and time, and other details. Last execution date and time, pretty important if you have a timeline of where your exploit was executed from. So you can focus in on these and look at any of the background application processes that could have been run in that exploit timeline. So prefetch. Prefetch is a feature of the memory manager that can improve the performance of the Windows boot process. So it reduces the time it takes for programs. It stores files required in the RAM. So as soon as the application is launched, would caching be sort of an apt? It's sort of a tangent, I guess, but
I mean, it's just preloading the files into memory, so it doesn't have to do that.
and it helps make your startup of your apps and stuff that you can consistently use more efficient. So that's sort of the C Windows prefetch directory with the .pf extension. That's the extension of this file. And it uses the Win prefetch view tool. You can use the Win prefetch view tool to analyze these files. So again, you extract details like the number of times the program was executed and the files associated with executables. So basically, you can look at some of these files that have been, loaded faster, see if that has potential correlation to any attackers. Again, just going over every single possible point of entry and then analyzing it. Do you want to take this?
Yeah. All right. So SRUM, the system resource usage monitor. Imagine task manager, but beefed up. So you get application resource usage, energy usage, notifications, network connectivity, and it gives you this over a much larger scale, 30 to 60 days. So you can view this inside of Task Manager, but if you're working off of a triage image that you took of a compromised computer, or you just want to do it a different way, you can take the SRUM database file, use that SRUM ECMD parser to go through that and create a readable image from there. Also, always make sure that the database file does not need to be repaired. This is a pretty common thing whenever you're taking triage images of Windows systems. It's not always completely intact, and when you try to parse it like that, good things do not happen. Normally, whenever I've done this and I forget to do it, my terminal just glitches out and I have to restart it. Just always make sure to do that if you're ever doing this, so you get a fully intact .dat file, and then you can go through and do everything. And one neat thing about this that I haven't really found anywhere else in any Windows artifacts is the FaceTime field, just how much time that application is actually on the screen, user staring at it, or maybe not staring at it, but it's just like the amount of time it's on the screen. So normally that doesn't matter too much. Just like web browsers, Excel, those are normally the highest up there. But if there's other things that you're looking for, I mean, it can be useful. It's just something a little interesting to look at. All right.
So you guys can actually just hit your Windows tab if you're on a Windows machine, and you can look up Event Viewer. It's an application that you won't have on these machines. And so it's built in, right? It's native, it's provided to you, it's a domestic thing. Quick little story, I'm not going to spend too long on this part, but I once left my computer a couple weeks ago, about 9:00 p.m. I finished working at Siebel one night. I left it in my bag, and I thought stupidly that if I threw it on sleep mode, I'd be fine if I just quickly went back home and turned it back on. I don't know. With Macs, because being a Mac user, I was just used to shutting down properly and doing all that. I didn't put it on hibernate. But how was I able to find out what exactly happened? So I went home, started mopping, cleaning up my place for like 2 hours. And I touched my bag and it's hot. It is really, really hot. Now, I'm making bricks, you know what I mean? I'm like super nervous as to, did I fry anything inside this thing? Well, you know, I didn't. Turns out there's hard limits that it's set to actually do, but I wanted to find out how my machine responded to that incident, right? I'm classifying it as an incident. So into Event Viewer, saw that there was a kernel power event critical at exactly the time, about 7 minutes after I left Siebel, and that it attempted to do an update at 9:07 p.m. because it was on sleep, not hibernate, and it actually tried to turn it on, even if I had the lid closed. How was I able to find that? Event Viewer showed me the message at exactly what time and what exactly occurred. So it's a good daily life thing. Something happens on your computer, you want to troubleshoot, you want to find out what exactly went wrong, but you weren't there to witness it that very second. Well, you know, like a security analyst would, you are your owner of your own device, so you can actually go through and check that out. It was really useful for me for that reason. Anyway, so that's Event Viewer. System errors, kernel power events, application events, security events. They all have different classifications numbers. They're known as event IDs. So Event Viewer tags them for you. And so you can filter for those. You're going to see on a slide or two from now what that actually looks like. But it's useful because you want to determine IOCs. It's useful because you want to be able to see what events were triggered from an action that I suspect happened. And I need to know what time it happened. So there's your timeline. There's popular event IDs of interest. Don't just go off of these. You can also use what we talked about a little bit earlier. And then I'm happy to send you some Microsoft Learn resources that show you an actual event table of event IDs that are updated and kept pretty much for you to feel. Yeah, so this is the interface. I know it's not clear to see, especially if you're sitting back there a little bit. On the left-hand side, you got an error code of 1,000. That's your application error. So I tried to install a new NVIDIA driver on my laptop one night. And this is stuff I just pulled from my computer. So, it didn't go through. It failed, right? There's the application error on the left-hand side that shows me exactly what time it happened and, how I can trace exactly when, right? On the right-hand side, there's a simple log on. So at 3:38 today, I powered on my computer to log on. I actually restarted it earlier, tried to go back in. So, that's how you can actually verify what actually goes through on your personal device.
Mhm.
This is very useful, not just for security analysis, but for your daily life.
Yeah. And as a quick note, if you're ever performing like remote forensics on a computer, like if you pull some event log files off of a compromised box, you can also just import them into Event Viewer and look at them that way. So, I mean, it works for pretty much anything you need it to. Oh, yeah.
Are these events stored forever or are they like eventually deleted after the time span?
Yeah. You can change, I think, your audit policies to determine how long you keep the event logs. I don't know what the default is,
Default is either.
but
But there's
it does. I don't believe it keeps them forever.
it is an audit policy.
It would be too much data, so it'll probably flush in person at time.
All right. Now we're going to be getting into linking specific user actions to various events on a system. This is always fun stuff when you're trying to pin the blame on who did the thing. Almost like a murder mystery, but nowhere near as fun. Unless you really enjoy computer forensics, in which case this is an absolute thrill. All right. So first thing, I briefly mentioned that before, object access logging. So by default, Windows does not actually log file or folder access. I thought this was kind of weird when I first found out about it, because that seems like something they would do, but turns out they don't. So you either need to turn this on by a policy, just like that command there. You do it with audit poll. That's what I ran on my own computer. I don't know, a few months ago when I was going through the CCD training. It's like, huh, that isn't on by default. Or you can use the group policy object, either or. But again, if you do this, just like base everything access, this can be quite intensive because you may not see it, but in the background, a lot of stuff is always happening. So this can add up pretty quickly. And you don't really need to actually have this for a few main folders, or like what you generally use from time to time. It doesn't have to be everything, but enabling this for a few specific areas that you think are sensitive is always a good practice. Also, brief mention about the handle ID. Every object that's being files or folders has its own unique identification number, and you can use this to correlate all the actions on an object through security event logs, system event logs, pretty much anything that saves the handle ID. All right, some key event IDs in the security event logs, seeing access attempts, objects being deleted, access of an object ending, 460 and 4660, 4658. Those two can get a little funky whenever someone is still accessing a deleted file. You just got to keep an eye out for what the heck is going on and make sense of it in your head. But those are pretty easy to be looking through in the event log for stuff that you think is suspicious. Also, shell bags. As much fun as like the name is, this is a bit of a pain to actually go through and parse. Shell bags are the log of all folders that a user viewed on the system. And this isn't just ones that are locally, this also includes external drives, whether it be like USBs, network file shares, all that jazz. So with shell bags, we can determine pretty much anything a user viewed, and even if it doesn't exist anymore, which is very nice if the attacker is deleting files. The registry keys are stored on those addresses, and once you're able to find those, you can use shellback explorers to parse all of them. This is a bit of a pain because it does not work all of the time. Yeah, you just because I had a lab where I was doing this for a while, and for whatever reason, it wouldn't work. I had to figure out another way, but generally, this is a very good way of figuring out, especially deleted files and remote accessed files. It's very good. Okay, and then link files. Anyone have a clue of what link files might do?
They are using shortcuts.
Exactly. This is quite nice they've made the acronym like that. So yeah, shortcuts to files or folders. And they don't just contain the path the file or folder. It also has file attributes, serial number, where it is. Especially if it's like on a remote network share, it'll have the host name and or the system MAC address, which is pretty good, especially when you're trying to work with, let's say, lateral movement people moving and opening files from network file shares. Very useful. Link files are oftentimes created automatically whenever a user opens a file, or they can do it manually with the create shortcut options. Like whenever you want to access, let's say, Firefox, make a shortcut on your desktop instead of going to that one file and program files every time. This is what you're doing. And so because this offers a good way to see what the user is actually accessing, it's always good to grab those off of a compromised computer. You can do that the way this is describing with CAPE. You can set like a triage profile, or no, a triage target to grab all of these link files wherever you want to look for them. And once you have that, use LECMD to parse it. This is pretty straightforward. Once you have it, you can see what was accessed. Bada bing, bada bang, bada boom. Straightforward. All right. Okay, this is a bit of a fun thing. If y'all want to follow on with, like, let's say, Event Viewer on your own Windows computers, if you have one, that's always good to get in the habit of, or get a little practice in querying for stuff. So we've mentioned skeletal tasks before, similar to cron jobs on Linux. Just also a good way, not just for system administrators to be doing things, but also for attackers to gain persistence. You have a whole bunch of different things that attackers can use with the schtask.exe. Create, delete existing queries, run them. There's a lot of things you can do with scheduled tasks. Here are some malicious examples. These are stuff that I've seen in labs and documented. Yeah, well, I changed the name of the task, given that, whatever proprietary lab stuff. I want to be showing that it's just a way to say it. So the first one, that's going to be running a PowerShell script from the downloads folder. If you can't tell from the name of the PowerShell script, it's probably not something you want to be running. And it runs it daily at 4:20 a.m. and it bypasses script up logging. So this is just a good way for maintain persistence every day. If you're running that consistently, the attacker always is way back in. Same thing with the second one, but this time you're loading a malicious DLL and running a function from there. Now on to detecting this. There's a whole host of logging related to scheduled tasks actually running, being updated, deleted, executed, completed. Didn't mean for all those to rhyme, but they all ended in ED, so it ended up working out. Same thing with Windows security log. If you have that audit policy enabled for scheduled tasks, you'll see them there as well. Same thing with the sysmon event IDs. That's if the scheduled task creates a process, then it will show up there as well. That's not entirely related to scheduled tasks, just the result of it. You can tell via the parent process ID. Linking it there. Same thing with 4688 and the Windows or security. Yeah. I'm sure not right now. Yes.
Basically, what you're seeing is the pattern, depending on what exactly you're looking at in the Windows application, right? The actual event IDs themselves, they're similar in terms of what group they're a part of, right? Does it make sense? So 46 all the way to 47 versus 100 levels, right?
Yeah.
Sequels, what? It's something like,
I don't know off the top of my head.
damn,
Yeah.
I forgot.
Sysmons or event IDs 1 to, I think, 50 or so. Those are very low. You can tell if it's sysmon just because it's on the very low end of the spectrum.
Yeah.
And I've I guess quick aside on that, in terms of filtering by certain process IDs are a very helpful tool to use if you want to see file creations or deletions. Filtering by these can be a powerful way to just get the information in front of you really fast in an organized way.
Cool. And now actually going through your event logs and looking for someone that's doing malicious things with scheduled tasks. So just as a quick note, this is the bottom. These are queries that I wrote for the Elastic Security Information and Event Monitor. These will not work for Event Viewer. just because it's two completely different query languages. So a good point of practice, if you want, try and convert what these Kibana queries do into what actually works for Event Viewer. So it's pretty simple stuff. You're looking for scheduled tasks, creating a process with event code 1, whether it's scheduled tasks is created with 106, stuff like that. We're able to narrow down pretty quickly what the heck is going on with any given process. And always good things to look for, stuff being executed from non-standard directories. If it looks suspicious, it probably is. Also, different binaries that probably shouldn't be on the computer. And also, if a scheduled task is running commands from PowerShell, like loading DLLs or other stuff, generally people aren't, or system administrators aren't doing that. So that should set off some red flags in your head. And then this is like a bunch of different patterns that I put together for Kibana, where you're looking for a process being created and the process command line, including all sorts of different things that we already talked about being suspicious, where it has those high-risk patterns that you want to find quickly. And always remember, this is like a general thing whenever you're doing any sort of forensics. It's super easy to get locked in on like one data source. You're just like, oh, I can feel that there's something suspicious in here. And you just keep digging into it. I've fallen this trap a lot of times myself. You always have a bunch of other data to be looking through. If you're stuck for a second, go look at something else real quick. Maybe it'll adjust an idea. You give your brain a break and it thinks of something. And you can always use that other information, not just to find other things, but to build a stronger story of what happened. And that is really what we're looking for, complete understanding of any given incident.
As your hand.
Yeah. All right. And then lastly, but certainly not least,
Yeah, all right, so GPOs, I don't want to talk too heavily about those today, mainly because at some point later in time, we're going to look into system hardening together as a whole, not just for the CyberForce and CCDC stuff, which you'll get exposure to earlier if you do that. That's why I really recommend you do. But the idea of using GPOs is part of the forensic scope of your investigation, right? So let's go to the next one. Group policy objects are pretty much only available for you to actually view if you're on a Windows Server platform. So you're not going to actually see this on your computer because you're most likely running Home or Pro, right? But if you're running Server 2016, 2019, 21, 22, and 25, you will be able to see an Active Directory network over here. You'll have Server Manager, all that stuff, right? So it could be as simple as I want to enforce a password change every X days or X character length, right? Or assign user groups like X user to Y group with Z privileges. At the end of interacting with the interface, again, we'll do this later, GP update force, so your changes go live when you actually do this. Sometimes group policy updates are forced if a malicious actor is inside. Sometimes GPOs are you really want to be able to look at to say, well, I'm going to ask a question of what lack of a policy enabled somebody to actually get somewhere. On the next slide, I think I listed that out a little bit too. Like I said, greater detail next time around. But if the policy was in place, the flip side is, would it have prevented X or Y from happening, right? So the other thing too is, do other users or certain groups have more power than they should within a system? And so if not, then you're not properly segmented. Event IDs are also important because GPOs being triggered or being abused trigger specific event IDs that you can look up in logs that we've spoken about today too. And there's an example, passwords, for example, right? So what it might look like if you're just trying to look at all facets of password enforcement. Now, a lot of folders, right? You can right-click it, enable a GPO or set up one by default, and then on the right-hand pane, you actually see what it looks like when it's displayed there. So you can go in there and change those values. Yeah, I know that's overwhelming, but a lot to see there.
All right. That about wraps up the presentation. Does anyone have any questions before we hit up announcements?
Yeah.
I just need to make a quick clarification. There are two sets of GPOs that are out there. There's local GPO and there's Active Directory GPO. I would think that everyone's Windows computer would have a local GPO. For example, you can just type in local security policy
Mhm.
and things will get enforced, although it's not as featureful as the AD one. And the AD one is a bit interesting because your local GPO enforces the policy on your local computer, and I believe that applies to more or less local accounts and stuff like that. Whereas your AD GPO applies to AD users. And it also affects what AD users can do on the computer. So it is a mess, and sometimes you really have to wrestle with this whole system. But you know, also this is a great place to. I can't believe you didn't say this, but when you mentioned elastic queries,
Yep.
why did you not bring up Tracerfire?
Oh, you're absolutely right. All right, time to show out. All right. Whenever we do end up using Tracerfire, like the CM that we or the SIM that we use a lot, you also use like the Azure one. But Elastic is probably, in my opinion, better. It does seem a little bit faster. The query language is much easier to use. So if you do end up using doing Tracerfire, which I hope all of you in here sign up for, it's a great experience. Ron will tell you because he built it, but also us that have competed in the past, it is also very fun, and we get to beat down on Purdue, which is always good. But learning how to
They tried to assemble a team of PhDs to beat us, and we narrowly win.
indeed
Yeah,
too cracked.
too correct.
Definitely not Ronan hard carry.
Four.
Oh, that was
No,
fun.
6.
Four.
It's 5, it's 5.
Five.
5.
4, 5, 6. Yeah.
My bad.
It's 5. Yeah,
Yeah.
it's incredible exposure, and you
Mhm.
will honestly learn so much by sitting at your laptop for a long period of time. And you know what? It feels good to say, Purdue, you suck. We're better. You know?
We beat about 25 points, by the way.
Final power, man. It's nuts. We woke up that morning, they were up a couple hundred. We were like, sweating bullets a little bit.
Yep.
Yeah, but Elastic was very smooth, man. I mean, it showed you so many things from all the stuff that we were talking about, summarized in a very readable format. Obviously, it's no way that we can present it to you that's super readable, but if you go and investigate it using an actual software that's readable, imagine how beneficial that is for you.
Mhm. All right. Now,
Yeah.
yes.
A lot of the stuff you're saying that you're looking through logs, what are the protections that stop the malware from just deleting the logs?
Well, hope and pray that they don't. Most,
For
yeah.
Elastic and for the remote
Mhm.
ones, you can't because they're sent over the wire. You can
Yeah.
only intercept the logs.
Mhm.
You cannot delete the log. The local logs, yeah, you can delete them.
Yeah.
That's why usually there's a synchronization process between local events and remote events, so that the local events get actually sent to the remote server, such that if they get nuked, there's still a backup call inside of your Elastic or whatever.
Yeah.
To add a caveat to what Cameron was saying, like if you have like a Ronin level malware exploit, sure, you can basically go and delete logs and be stealthy. But overall, if it's like a recurring process and stuff like that, like if the process is running every day or runs up on startup automatically, there are ways of detecting it based off, your task manager, how much energy you're using, stuff like that. So if something is like consistently every single day infiltrating and exfiltrating like data from your laptop, there are methods of finding it out, even as simple as like energy usage for certain tasks. So all hope is not lost, but it is pretty bleak if somebody, let's say, breaks your hypervisor or something like that.
Yeah.
You're kind
Also, you should absolutely monitor modification of any log files other than authorized process,
Yes.
right? Like if any unauthorized process tries to modify or delete the log files, like that should be an all hands on deck situation.
But
It's kind of cool.
Like delete the log file and delete the log that says they delete the log.
yeah, that's kind of how it is.
For most stuff, right? Like
Yeah.
if we don't have like internet and whatnot. Yeah.
Yeah. That's the end goal for CyberForce, where we'll hopefully set up Elastic Stack and just log stash forward everything to our own Elk Stack box.
Now, real quick, let's get through 2
Announcements.
announcements.
True.
Y'all look out for a Google form. Still a little bit delayed. Sorry, I'm just trying to work on his Likert skill question that he suggested. I'm not trying to make it too long for you, but I want to get everything I can so I give everybody a fair chance of being placed on a team that's good for them. Good for them. That's the emphasis here. And then for Cyberforce, I'm gonna start texting you about it tomorrow. So like when he talks about what the strategy is behind Elastic and things like that, it'll start to make sense when we actually meet up. So that's pretty much it from me. We're at time.
Right. At
Any other
time.
things we want to talk about? You can come to us after. Event viewer log file size, 20 megabytes by default.
It can be very overwhelming, to see like all the tools and stuff that you have to use, but the process is the same. You're basically looking for a specific subset of data, then you want to have tools to actually trace and look through for anything that seems suspicious.
Mhm.
And you can apply this, I guess obviously apply this in practice through TracerFire and other competitions. But I guess the more you get exposed and the more you poke around your own system and try to harden your own system, the better of an understanding you get about it.
And you won't get better if you don't practice. Like, if you have the time, go do some free labs. Try FA2025, CCD. Hack the Box has gotten some pretty good blue teaming labs. Like, if you got the time, start putting your skills to the test, start internalizing this stuff, and then you'll be kicking butt in no time.
Yeah.
Hopefully produce butt.
Our entire meeting content,
Go
most of
team.
it is a blend of stuff that you can also see in CCD and try FA2025. But if you want to like fundamental and kind of introduction to it, Windows Forensic 1 and Windows Forensic 2 rooms on try FA2025 pretty much cover a lot of that.
I guess.
All right, yeah.
All right. Thank you much. Have a good week, y'all.